Yes, we'll do problem number 4. Can you see the screen, the Word file that I've shared?
Yes, sir.
Okay. Yeah, the whole diameter is missing in the diagram. We'll give that. Okay. Yes. Okay. So we'll see the question. Okay. Problem number 4. Right. Write the manual part program for the part shown below using CNC mill. Select the tool. For 5 holes to be drilled. So only write the manual part program for the part shown below using CNC mill, right? Or they will only write. They will only say write the manual part program for the part shown below. Okay, and these details will be given. What 5 holes to be drilled to be reamed to diameter 10 mm. Okay, right? It has to be drilled, and if you remember, the types of drilling operations, we have the varieties in that. One of them is the counter bore, the other one is the reaming. Okay, so here they are telling us to, after drilling, it has to be reamed also. That is to provide smooth surfaces to in the places where the hole is being drilled. Okay, so reaming has to be performed. Yeah, right. Now for this, Okay. Now for this, we'll see what to do. Okay. So 5 holes have to be made. Yeah. Right. So right. So first, let us write the coordinates for the first thing is that anyway face milling has to be done. Okay, so the coordinate for the first hole over here is 25 comma 25. Second hole we can go for just a second. uh, right, so yes, they're going in here. So the second hole will be here. We'll take this x25 y75. Then third one will be at a distance of 75 comma 75 over here. Fourth one will be at a distance of x will be 75, y will be 25, right? Okay, so the remaining is not required, is not there. Okay, right, and there. Okay, we can assume the thickness of the plate. Okay, can assume the thickness of the plate if they are not given. Right. So now, so after this, billet size, the overall size of the plate itself is 100 by 100. Okay. Right. Okay. Okay. So we'll start writing the program. Yeah. So for this, okay. In second. Yeah. Okay. So first start with the percentage symbol, then program number, first percentage, next line, capital O, then followed by 4 digits, right? Then N01, G21, G94, G90. Okay. So, right. So absolute coordinate system, you G21 in SI units, right? And so on. So next line, please, here it is as N01, 2, 3, 4, and so on. Please, when you write it as, please write it as N01. Next line should be N05, third line N04, sorry, N10, N15, and so on. Okay, right. So N02, okay, G28, X0, Y0, okay, and Z0. Then M06, so next line M03, M06 for tool change, M06, T0101, then M04, G43, H1, which is to remember the tool length compensation to be registered in the, to be stored in the register. Okay. Then start the spindle, M03, S1500, M08. Okay. Right. Now get the tool. Okay. Now we are going to directly take T01 for the drilling tool. So here they have asked us to do reaming also. So first we have to drill the hole. Okay. And then go for reaming. Okay. Right. So, but please, when you execute the program or also when you write it in the record, you first write the lines for face milling. Then second tool will be for drilling, and third tool in this case will be for reaming. Okay. Right. So yes. Now after the spindle is started, we'll get it to, we're going to do the drilling operation. So we'll get the tool to G00X X0 uh, Instead of this, we can directly get it over here at x25, y25, and z5. Yeah. Right? All right. So now, see, in this case, in the previous class, if you remember, we did only drilling, which was for only for 2 holes. But here you have 5. Some cases there'll be even 100 holes that has to be drilled. So every time we cannot ask the tool to, to say, for example, just a second. So if we have the workpiece, and a hole has to be made here. Okay, we cannot and here and here. We cannot tell the tool always to be here, come to safe distance, then go inside, drill, then come back, right? Then move here, go to safe distance, then go down G01, G00, writing it several times. So instead of which makes the program lengthier as well as the program to be written a more tedious one. Okay. Instead of that, we can put it in canned cycle. Okay, we'll see the canned cycles for the drilling and reaming operations. Okay. Yeah. For drilling operation. Okay. Now for a smaller depth of cut and all those things, we can directly use drilling cycle, which is denoted by G81. Okay. So if you remember the drilling operation, directly the drill bit tool will be going inside the workpiece by removing the material for a certain depth. So all it needs is that first thing is that it should come to a safe position above the workpiece where it has to be drilled. Then second thing is that it should be fed to the bottom of the hole. That is, the drill bit has to move vertically downwards inside the workpiece. Then the drill bit has to come out to rapid safe position, that is above the workpiece uh, surface, right? So that the drill bit can then move on to any other position, or it can go back to its home position, right? So G81 is the code for drilling cycle. We have to give what is the X value for that particular hole, Y value, Z value, and R value, right? 5 mm above the workpiece surface, right? Above the workpiece surface. That is nothing but the Z value, right? If you give Z, instead of giving every time Z5 and all those things, 5 if you give, right? Or 10 or even 2 mm, generally 2 mm is not preferred. Okay, that is the initial safe position. And at what speed the drill bit has to be inserted into the workpiece. This is denoted by F. Okay, right? So these are the this is the format and syntax for the G81 drilling cycle. Okay, right. So now we'll come back over here. Okay, so G43 H01 so spindle start. We have now bought the tool to X25, Y25, Z5. Okay, onto the first hole over here. Right now, next is G99. Okay, that is get the tool to the safe height. Okay, G99 denotes get the tool to the safe height. Right. return to safe position point in canned cycle, right? Next. So now starts the uh, G81, the drilling cycle. Okay, we have already given what is the X value, Y value and Z value. We have to give only the Z value now. Okay, so Z minus 30 because the question they have told it has to be drilled up to, okay, they have not given the depth. Okay, we can assume the depth, okay, for up to 30 mm. And R5, that is return to safe positions, return to 5 mm. Okay, that is, so if we have this is X coordinate, Y direction, this is the Z direction. Okay, the tool, we can ask the tool come back to Z to a point of 5. So the tool will be here. So there will be a distance of 5 mm, right? Okay, that is what we are, and the tool should move at a speed of 40 mm per minute. Sorry, SI units, no, feet per minute. Yeah, right. Okay, right. So next is what after this. So first hole is drilled. After that, it will come back to the value RZ5. Okay. Then is what the tool has to move to its second hole. We have to give only the coordinate. No need for it to ask that it has to go inside so much depth, come back, and all those things. Only give the coordinates of the next hole. That's all. So next hole is at a distance of Y75, X25. So already X value is 25 only. So only Y is changing. So we'll give that. Then in the next line, we'll ask the tool to go to the third position. So X75, Y75. Then fourth one, X75, Y25. And then finally the fifth one, X50, Y50, 5 holes are there. See? Right. So after that, then once it goes there, G80, M09, M05. Okay. So G80 canned cycle, cancel the cycle. Okay. Right. That is, we are coming out of it. Cancel the canned cycle. Then M09 spindle stop for M05, M09 is coolant off. Then go back to its home position G28, X0, Y0, Z0. Then change the tool M06, T0202. Okay. Then next line G43, H02. Start the spindle M03, S1000, sorry, 750, coolant on. So in tool number 2, here we are going to use reaming tool. Okay. So nothing but to give finishing operation for the drilled hole. So generally the speed will be less. Okay. And then get the tool to the position of the first hole G00, X25, Z5. Okay. Then G99, G85 is the cycle for reaming. Reaming cycle G85. Okay, right. A reaming tool will look little bit similar to drill bit, but not having so much of depth of groove. Okay, here what is going to happen? First, the tool will be at a safer height, just similar to the drilling cycle. Then then the tool has to be inserted into the already drilled hole up to the bottom. Then the reaming tool has to return back to its safe position above the workpiece, right? So the syntax is G85, X value, Y value, Z value, and R value, and along with that F. Okay, right? Along with that is the feed rate also. So G85, Z minus 25. Just a second. We'll put it over here. We have given 30 for drilling. Reaming also we can give up to 30. Then R3. Okay, or you can give return to safe position R5. Then F75. Okay. Then similarly give the coordinates for the second, third, and fourth and fifth one. So Y75, third one X75, fourth one Y25, fifth one X50, Y. Then it's going to be G80, cancel the cycle, spindle off, coolant off, G28, X, Y, and Z zeros, end the program with a and then percentage symbol, right? Okay. Yes, copy down this program. We'll see the simulation. Copy the program fast. Yes, copied it down. Over.
Excuse me, sir.
Over.
Can you show the diagram, sir?
What?
Diagram, sir.
Diagram.
Yes, sir. Yes, sir. It's over, sir.
Okay. We'll see the simulation. Yes, first we'll go to CNC mill. So the program would have been typed in Notepad, so we'll at that. Okay. Then go to define blank, 100 by 100, thickness 30. Select a CNC machine. Check for errors. Yes. Now go to the tools that has to be selected. So first we'll go to drill. They are told diameter of 10 mm. So and then it has to be reamed. So we'll go to drill and reaming. So we'll go to reamer select 10 mm reaming tool. Okay. Here you can see the reaming tool. Okay, and always ensure that the longer than the length of the flute is longer than the depth of the hole. Okay, right, and also this one also the length of the holder face. Okay, this should also be longer than the depth of the hole. Check for any errors. Now directly yes, this is the place where the first hole has to be drilled. Now the drill bit is 5 mm above the workpiece surface. Actually here we are not showing the face milling, but actually since we have already taught y'all how to do face milling, it's the same lines that has to be repeated. Okay. They are only showing you the other portions, okay, but in the exam and I mean even in the record and internals and record and exam, first always do face milling. The tool gets inserted, so if you look at it on the screen over here, N07, G99, G81, Z minus 30, okay. X25, Y25, it's already there. So canned cycle for drilling has started. It comes out for a distance of the surface. Then the next thing is nothing but no need to give G00, G01, nothing. Just give only the whichever the coordinate is changing, the number for that. Okay. So it will perform the operations accordingly in which it is the cycle is running. The fifth hole goes back to its home position, change of tool. Yes, the reaming tool comes now for a safe distance. And now you already the drilled hole, the surface, the inner surfaces are colored with green. After reaming, since it's a different operation, in this portion, that is the drilled hole, the color will change as an indication. So you can see the green color has now changed to pink color, which indicates the reaming or the other operation has been performed. Yes. Yeah. Right. So this is regarding the problem number 4 simulation. So yes, copy down this diagram. Problem number 5. Just a second. Right? Yes, copy down this. So again, it has to be the 4 holes have to be drilled. Sorry, not 4. There are 2 different diameters of holes that have to be drilled. Totally 8 holes, 4 of which are having a different diameter. The other 4 are having a different diameter. Okay, totally for a depth of 40 mm. Copy it down. Copy down the diagram. Okay, over. So we'll write the coordinates for this. So first let us write the coordinates for the bigger hole. So 25 comma 25. Second one will be 25 comma 75. Third one will be 75 comma 75. Fourth one will be 75 comma 25. So these first four holes is for the holes of bigger diameter. Okay. Then fifth one will start here. So this will be at a distance of totally 120, right? So okay, so it is going to be x value is going to be 60, height is going to be again 60, right? It's going to be half of the length and width of the plate. Okay, total length and width is 120, so it's there exactly at the center. Okay, then for next hole over here, this particular one will be at a distance of okay, so 60 plus 30. So here it will be 90 mm, and this distance will be 60 y value. Sorry. X value will be 60. Y value is hole will be at a distance of x will be 90, y value will be 60, and the last hole will be at distance of x value 60, y value will be 30. Okay, so yes. So the program starts with a percentage symbol, then capital O followed by 4 digits. Okay, billet size is going to be, yeah, that is already taken up. So billet will be 120 by 120 into 50 mm. Okay, now whatever they asked, okay, it's a 40 mm hole that has to be done. All right. So hole depth is has got a higher value. We'll see that. Okay, so now N01, G21, G94, G90, then N02, G28, X0, Y0, Z0. The next line M06, T0101. Then next line G43, two length compensation H01. Then start the spindle M03, S1500, start the coolant M07. Then get the tool, drilling tool to do the larger diameter, the required portion G00, X25, Y25, Z5. Okay. Then G99, G83. So G83, okay, G83 for drilling cycle, okay, where whenever the hole depth is larger, what do we do when we do a drilling hole? We first drill, we insert the drill bit into the workpiece for a certain depth, come back and insert it back inside once again to perform some more depth of drilling and then return back. Okay. Right. So there are two things in doing this. There are two ways of doing this. What is that? What is that? I will tell you. Yeah. So the first thing is that okay, the drill bit will be at a safe position. Okay, then from here it is going to be inserted for a particular depth. It's called as the peck depth. Then it return back to its safe position. Then in the next step, from here, it is again going to go for some more depth for next peck depth, that is 5 mm, then return back, then go up to the next 5 plus 5, 10 mm. So next incremental distance is again 5 mm. Then it will return back up to the safe position. Okay. Now when the hole depth is longer, okay, larger values, unnecessarily this tool is moving over large distances at a smaller pace. So what they can do is that in such cases, what will happen is initially the tool will be here, peck depth distance 5 mm. Next, the tool will go back to its initial point over here. Right? That was what was happening. When you give G83 cycle, what will happen is that in the further on distance, this once it reaches here, the next distance should be here, and then next perfect distance will be here. So now every time say for example the tool is over here, it has to reach till this point and then come down once again to do this particular depth of drilling in peck cycle, in peck depth. Okay, instead of that, instead of moving for such a long distance, what we can do is that after this step is over, that is after the tool is over here, we need not have to go back till here. We can give only a small reverse feed. Okay. So from here, the tool will go back only to this position. Only a small back step, not until the origin point. And now the tool can now go here, covering this distance. Anyway, there is no material in this particular place. So we'll be saving so much of time for the movement of the tool for such a long. Okay, so drilling operation there is no change, but the thing is this. So it depends upon what code we are going to use. So even if you remember, when you do drilling operation, say for example, especially when you want to uh, uh, do any hole in the drill a hole in the wall, okay, for a larger depth, every time we don't take the drill bit with the drilling gun outside the wall and then go inside. After a certain depth, we take it a little bit reverse, very small distance. Still, the drill bit will be inside the wall only, right? And further on, push it in front to make some more depth of cut. Okay, so that is what we are trying to do here. Okay, so for that, the drilling code is G83. Okay, so if you look at this diagram, okay, so first spec the distance, all right. Now coming to the second diagram. So initially from point number safe distance, it will go up to here. Right. So it is going to go up to here, first spec distance, go back, reach this position. Then next one, what will happen is that from here the drill bit will go down to the next spec distance, return back. But while returning back, it will be returning back only for so much, not completely. Right? So there are two ways of doing this. Okay, one is we can go up to the initial or only up to the required back step. Yes. So the syntax is almost same only over here. G83, X, Y, and Z coordinate values, R value, initial safe position, and Q, depth of each peck. Okay, for how much depth should it go? 5 mm, 3 mm, and so on, and then return back and go, right? And finally the feed rate. Yeah, right. So here I will go to the program. So we were here in the program. So yes, G99, G83. Okay, Z up to -40. Peck depth Q 5 mm. Return by 1 mm, or we can even give up to 5 mm. Okay. Initial safe position, right? Then feed rate 100 mm per minute. Okay. Then next one, the next value. Okay, it's here. No, sorry, I made a mistake. So this is 80. 80, isn't it? So this Y value should be 105, not 1, not 75. It is 105. Okay, third one will be, if I'm correct, 105, 105. Right? So second hole, X value 25, Y value 105. Third one, X value 105, Y value is also 105. Fourth one, X value 105, Y value 25. Okay. Then after that, G80, cancel the cycle, M09, M05. Okay. Then return to home position. Then go to tool change M06, T0202. Tool length compensation G43, H02. Okay. Then start the spindle M03, S1500, M08. Okay. Right. Now, next one, G00. Here we can get the tool to hole number 5 directly, position. The value is, if I'm correct, okay, X30. Y will be 65. 65. Half of 120 should be 60. 30, 30, 30 plus 60 only. Cannot be 65. It is 60. Okay, and Z5. Okay. Right. Next. Then start the drilling cycle once again. G99, G83, Z minus 40. Pet depth is going to be 5, R5, F100. Yeah. Yes. Next one, X60, Y90. Then the next value, X90, Y60. And finally, X60, Y30. Then cancel the cycle, G80, coolant of M09, spindle stop M05. Then return to home position, G28, X, Y, and Z, all three coordinates to be 0. End of program, M30 and percentage symbol. So copy down this program. Copy down this program. Yes, is it over? Yeah, over?
Excuse me, sir.
Yes, tell me.
Can you go to previous page, sir?
You want the diagram?
Yes, the table, sir.
Okay.
Yes, sir.
Okay. Yes, others program is over. Right, we'll see the simulation for this. Okay. Right. Yes, we'll extract the program from the notepad. Okay. Give the Y and Z values 120 by 120. Depth of hole is for 40 mm. So let the blank thickness be at least another 10 mm. Okay. Extra. Okay. Next, check the error. Oh, sorry. Select the CNC machine. Okay. Next should actually be tool selection. Okay. So the first tool will be okay. So diameter wasn't mentioned. Okay. So for the larger diameter, let's take diameter to be about 15 mm, and smaller diameter, let the diameter be 10 mm. Please make a note. Larger diameter for T0101, tool dia is 15 mm, and for tool number 2, T02, diameter is 10 mm. Okay, and yes, flute length is for 54, tool length holder is for 100 mm. Okay. Here also be careful. So initially, initially the length of the holder face is only 48 mm, which is very small. Okay, little bit smaller. Flute length is 43 mm. Already the depth of the hole should be 40 mm. So please increase both of them. Okay, and make it length of holder face to be 100. Flute length 50 or 60 mm. Okay. Okay. So now you can check for this and then go for simulation. So get the tool over here at X25, Y25, Z5. Larger diameter has to be drilled first. So you can see here that the drilling tool is going only for 5 mm peck depth every time coming out. Right, so here the third one. This is the second tool, smaller diameter hole. Tool return back to its home position, and that's the end of the program. You can see the same thing shown over here in line. So here you can see clearly when we use G83, okay, every time after each peck depth, the first depth comes back to its initial position above the workpiece surface. Second, depth of cut. Now the tool will return back above the workpiece only, see, till the starting point. Now third step, it goes back to the starting point. Fourth step, again to its starting point, which is above the work surface. So that is the difference between G81 and G83. So here also you can see that now it will return back. See here, it doesn't come only for a smaller distance only till here, it returns back up to 0 and comes down from its starting point. So that is when we need for G83. Okay, for larger depth of hole, that will be done only because the chips that is there inside has to be removed. Okay, right. For smaller depth of cut, it is okay. G81 can be used. For larger depth of cuts, G83 will be used. You can see the same thing happening for the smaller diameter tool also, because we have used G83 code. All right. Okay. Yes, we'll stop here for today. Answer your attendance. Niharika.
Yes, sir.
Okay. Nihar VS.
Yes, sir.
Okay. Nikhil R. Okay. Okay. Nilesh.
Present, sir.
Okay. Nirab.
Yes, sir.
Okay. Prajwal. Prajwal Patel. Prajwal Patel not there. Prajwal, yes, but.
Present, sir.
Okay. Prince.
Present, sir.
Okay. Rishabh Pandey.
Present, sir.
Okay. Rohan.
Present, sir.
Roshan Yadav.
Yes, sir.
Okay. Suman Sagar.
Present, sir.
Okay. Sagar Dutt Mathur. He's not there. Sagar Dutt Mathur. Okay. Sagar GB.
Present, sir.
Okay. Sanjay. Sanjay.
Present.
Okay. Sharanaya. Sharanaya not there. Okay. Sheikh Manan.
Present, sir.
Okay. Shobit.
Present, sir.
Siddharth B. Shankar. He's not there today. And Siddharth Sridhar.
Yes, sir.
Subramanya.
Present, sir.
Okay. Sumuk.
Yes, sir.
Tirumana Shetty Rohan.
Yes, sir.
Okay. All right. Okay. Yes.
Sir, Prajwal R. Patil present, sir.
Who?
Prajwal R. Patil, 036.
Yeah, give it. Okay. Okay.
Thank you,
Yeah.
sir.
Good.
Thank you, sir.
Okay. Yeah. Thank you. Write the records. Okay. Okay, and I'll upload the sections in the Google Classroom. Put your experiments over there.